move on to section C. In section C, we have this set of we have these compounds, and then we're expected to assign or to designate S and R configuration. So there are certain things you need to know before you designate S and R configuration. The first thing you need to know, S and R configuration can only be designated to a compound that has a chiral center. So step 1, locate your chiral center or centers, because some molecules can have more than one chiral center. So let me use my red pen. So when we look at this compound A, we're looking for a carbon that's attached to 4 different things. So if we analyze this carbon, it's attached to 2 hydrogens which are similar in these groups. So this is not a chiral center. If we analyze this, this is also not a chiral center. We'll be able to see that our chiral center is here, because this particular carbon is attached to a chlorine, a methyl group, this group, and that group. Therefore, this is our chiral center, step 1. Step 2, you need to be able to know that when you're talking about designating R and S, what it means when you say an ARA isomer or an ARA stereoisomer. You're trying to say it rotates light clockwise. Or another way to think about it, you could say it rotates light towards the right, because this is my right hand, right? So towards the right, like that. And then when we talk about S, it's the exact opposite. So S will rotate light towards the left. So that's an important thing we need to take note of. So first thing, locate your chiral center. Once you've located your chiral center, then we can assign priority. How do we assign priority? When assigning priority, we use the Kern-Ingold prelog convention, or Kern-Ingold prelog rule. I already made a separate video on that, so you can check it out, but I'll apply it here. So what the Kern-Ingold prelog convention tells us, or rule tells us, is that we assign priority based on molecular weight. So you're looking for the heaviest attachment, and then the heaviest attachment will get more priority. So let's look at the attachments directly. When we look at our chiral center, what's directly attached to the chiral center? We have a chlorine, we have a methyl group, but the first attachment is a carbon, right? We also have a carbon here, we also have another carbon there. We need to assign priority to these groups. How do we do that? So for those who are beginning, for those who've been doing this for a while, it's quite easy. You can just tell just by looking. But then I'll do this for the sake of those who are beginning to use the convention. So what you do is you draft a small table. You draft a small table. So after drafting this table, on this portion, I'll put the priorities, right? But then I'll start by describing the chlorine. So one thing you'll be able to see is that when I move from my chiral center towards the chlorine, what molecule will I find? I'll find the chlorine, right? Then if I move from the chiral center, what else do I find? Nothing else, so I won't put anything here. If I move from the chiral center to this group, the first molecule or the first element I'll encounter will be a carbon, right? And then this carbon is attached to 2 other hydrogens that haven't been shown in this structure. So I'll say 2 hydrogens. Let me use a different colored pen. So 2 hydrogens, right? And then after these 2 hydrogens, what comes next? There's another carbon. So I'll write that carbon. I could have gone further, but I think that would be enough. So after this chiral center, what's the first element I encounter here? Carbon. And then this carbon has 1 other hydrogen, right? 1 other hydrogen. Why 1? Because this is a double bond. Because this is a double bond, that means carbon needs to bond to 4 things. So 1, 2, 3, 4, right? And then after this hydrogen, what else do I see? I see another carbon. And then this carbon is bonded to what? It's bonded to 2 other hydrogens. I could have written the other one, but then I think that's enough. And then when I move from here towards the methyl group, the first element I'll encounter is a carbon. Then after the carbon, I'll encounter 3 other hydrogens. So 1, 2, and 3. So if you can make this table, you can clearly designate S and R, or you can designate priority. So the first thing I need to consider is, when I look at my first row, which has the highest molecular mass? chlorine should be roughly 35, carbon 12, right? So this should get first priority because it is the heaviest, right? And then when I analyze these elements here, they are all carbon, so they are the molecular mass is the same. And then when I move towards the next row, I'll be able to see that carbon here is heavier, so this should get priority number 2, right? This should get priority number 2. And then when I analyze the second row, you'll be able to see that this should get priority number 3. Therefore, the least priority group is the methyl group. And then after you do that, then you show it there. So this gets priority 1 because it had the chlorine. And then this one here should get priority 3. Yeah, so this should get priority 3. And then this should get priority 2. And then this will get priority 4. That's the second step. And then when that is done, all you need to do now is analyze. So the next thing you do is make sure your least priority group is on the dash. So what does that mean when you say it's on the dash? We mean this. So make sure your least priority group is on the dash. So I'll show you what to do when it is not on the dash. There are ways to force it to be on the dash. Okay, so since it's already on the dash, that makes our problem much easier. So all I need to do is move from 1 to 2 to 3. And when I move from 1 to 2 to 3, I compare which motion is that. So I'm moving this way, right? So if I'm moving this way, what can I say? This is S. So therefore, that's your answer. So let's do the same thing for the second molecule. Number 1, identify your chiral center. This is not the chiral center. This is not the chiral center. Our chiral center is here. So now that I've identified my chiral center, I use the same idea. For those who are beginning to assign priorities, I'll draw the table for you. But then with practice, you won't even need this table. You won't even need this table. You just have to look and you'll be able to see. Okay, anyway, so I'll describe the hydrogen. So from the chiral center, what do I see? Hydrogen, right? What else is there? Nothing else. So from here, what do I see? I see a carbon. This carbon is attached to one other hydrogen, right? It's attached to one other hydrogen here that hasn't been shown. And then after this carbon, there's another carbon there, right? And then this carbon is attached to 2 other hydrogens, right? And then when I move from there to there, the first element I'll encounter is a carbon. And then this carbon is attached to what? So it's attached to 3 other carbons. 1, 2, 3. It's attached to 3 other carbons. And then when I move, I think that's enough. And then when I move from here to there, what will I see? The first element I'll encounter is an oxygen. And then later I'll encounter a hydrogen. Once you do that, you can then assign your priorities. So you look at the first line. When you look at the first line, which is the heaviest in terms of molecular mass? Carbon is 12, this is 1, this is 16. So this gets priority number 1. And then this one will get priority number 4. And then these 2 have a tie. So how do we break the tie? We analyze the next line. So when we analyze the next line, we'll be able to see that this one should get priority number 2. Therefore, this should get priority number 3 by default. And then you just add in your numbers. So that means this will get priority number 4. This here will get priority number 3. Here we'll have priority number 2, and then there we'll have priority number 1, right? And then after doing that, you check if your least priority group is on the dash. So our least priority group is the hydrogen. Is it on the dash? No, it is not. The fact that it's not on the dash means we should proceed with caution. So what do we do? So for a second, let's pretend it's on the dash. So if we pretended it's on the dash, we'd move from 1 to 2 to 3. And then when we do that, what are we seeing? We're moving this way, right? And then if we analyze, that's S. right? However, because the least priority group is not on a dash, you reverse the answer you found. Therefore, the final answer and the correct answer will be R. So in my other video, I explained why we'll reverse, but then I won't go through that here. So let's move to the next one. So when you look at the next video, when you look at the next question, first thing, chiral center. After you identify your chiral center, you check for the constituents. So my pens are okay. So you make a table. So after you make that table, first same procedure that we did. So when you move from the chiral center, you encounter a carbon. Next, you encounter 3 other hydrogens. When you move from there to there, you encounter a carbon. This carbon is connected to what? To 3 other carbons. When you move from there to there, you encounter a carbon. This carbon is connected to how many hydrogens? None, right? But then the next thing it's connected to is a carbon there. And then this carbon is connected to what? So this carbon is connected to one other carbon, to one other hydrogen, like that. And then there we have our hydrogen. Let's assign priority. So when we are assigning priority, this will get priority number 4. So I can write that in advance. Right? And then there's a tie there. So we analyze the second row. When we analyze the second row, there's also a tie there. So one of these should be first priority. We analyze the second row, this one. So this one gets first priority. That means second priority should go to which one? Second priority should go to this one. And then third priority goes to this part here. So then we write that in. So this one will get third priority. This one will get first priority. And so third, first, this one will get second. And that one will get fourth priority. So what do we do after that? So the step is the same. Make sure your least priority group is on the dash. So now, since it's on the dash, I move from 1 to 2 to 3. When I do that, what motion is this? We're moving towards the right. It's clockwise. Because it's towards the right, this will therefore be R. Having done that, this is how you assign configuration.